In this video, we're going to do some fun things with the JackBord top. This will help us to get to know the JackBord better and also to learn a little bit of electronics. For this video, you're going to need a JackBord, a JackBord top, and some female-to-female jumper wires. About 20 should be enough. If you haven't already, it's worthwhile watching the first 2 videos in this series. In addition, these videos go hand in hand with the JackBord Journeys book titled Using the Top. The videos and the JackBord Journeys book can both be found at our website www.jackbord.org. Now we're going to do some tasks. In this task, we're going to connect an external LED to port pin A1 of the JackBord using the top. First thing to do is connect the power supply from the JackBord to your top as shown in the video part 2 of using the top. Once the power supply is connected, it should look like this. The completed circuit for this project is shown in the picture. We're going to go through each step now and show you how to make it. First, get a jumper wire and attach it to port pin A1. Once you've done that, take the other end of the jumper wire and attach it to the R input of the red LED. Take a second jumper wire and attach it to the negative output of the red LED. The other end needs to connect to ground. Your completed circuit should look like this. Check your circuit and then we can move on to the next step, which is using the JackBord to control the LED. For this step, you need to log into your JackBord's dashboard and go to the command page. Once there, type A1 space 1 at the command prompt and press enter. This will turn the LED on. To turn it off, type A1 space 0. You can try the pulse command, which will pulse the LED on for a set period of time. At the command prompt, type pulse space A1 space 500 and press enter. The LED should turn on for half a second and then turn off again. Those of you who are observant will have noticed that the A1 icon at the top of the command page changed as we ran the commands. In this task, we're going to use the same circuit we did for the first task, but instead of turning the LED on and off, we're going to use the PWM or pulse width modulation command to control the brightness of the LED. At the command prompt, type PWM space A1 space 1. The LED connected to port A1 should now be very dim. At the command prompt, type PWM space A1 space 50 and press enter. The LED should now be at about half brightness. And finally, type PWM space A1 space 99. This should bring the LED to its maximum brightness. If you want to learn a little bit more about pulse width modulation, have a look at the JackBord Journeys book called Using the Top. In this next task, we're going to connect 5 LEDs to the JackBord port A and use them to make a rainbow. The circuit diagram that we're going to build from is shown here. As you can see, there are 5 LEDs and each one is connected to a pin on port A. Looking at the completed rainbow, if we start from the upper left at port A, this is where all of the wires connect. They then make their way to the right-hand side with each wire attaching to one of the LEDs on the top. For example, if we follow the wire from port pin A1, we can see that it goes into the red LED. And likewise, port pin A2 goes into the green LED. And finally, on the right-hand side of all of the LEDs are the negative lines, and all of these need to be connected to ground pins. In this case, they're connected to the ground pins at the top of the JackBord top. Next, we're going to use the A-on command to turn all of the port A pins on at the same time. At the command prompt, type A-on and press enter. If you look at your LEDs, you should see the rainbow light up. To turn it off, type A off and press enter, and all of the rainbow LEDs should turn off. On the dashboard, if you watch the port A pins at the top of the window, you should also see them turn on and off at the same time. In this task, we're going to use the same circuit we used for the previous rainbow task. But this time, instead of just turning all the LEDs on and off at the same time, we're going to have them turn on in order. To achieve this, we need to use daisy chains. These are the pipe characters that you use on the command line so that you can have more than one command on the command line at the same time. As a quick reminder, the pipe character is on the / key on your keyboard, and this is generally near the enter key. The pipe key looks like a vertical bar. At the command prompt, type in the command shown here. Once you've typed in the command, check it and then press enter. If all is well, you should see the LEDs all light up in order. If you look at the port A icons at the top of the command page, you should see them change along with the LEDs on the JackBord. To check this, you can use your command history. Simply press the up arrow once on your keyboard and then press enter and the command will run again. Let's look at the command in a little more detail. First of all, we start with A off, and this turns off all the port A pins at the same time. Next, the A1-1 command turns port pin A1 on. This is followed by a D250 command, which produces a 250 millisecond delay. After that, we turn on port pin A2 and so on. As an extra exercise, see if you can make it so that the LEDs will turn off in reverse order. In this task, we're going to use a button on the top to control the user LED on your JackBord. If you haven't done so already, remove all of the jumpers that are on the top from the Rainbow project. Then reboot your JackBord by typing reboot at the command line. This will restart the JackBord ready for the next task. For this task, connect a jumper wire to port pin A1 on the JackBord and connect the other end of the jumper to pin 1 of butt 1 or button 1 on the top. Next, take a second jumper wire and connect it from pin 2 of the button to ground on the JackBord top. Your circuit should now look like this. We are going to use the BTP or button press command to instruct the JackBord to turn the user LED on when someone presses the button. To do this, on the command line, type BTP space A1 space L1 space 1 and press enter. Now press the button on the top, and if all is well, the user LED should light up white. The BTP command tells the JackBord that we want to have a button on pin A1, and after A1 in the command, we specify the command that we want the JackBord to run when the user presses the button. In the next task, we'll look at what happens when the user releases the button. In this task, we're going to tell the JackBord what to do when the button we created in the previous task is released. To do this, we use the BTR or button release command. This tells the JackBord what to do when a button is released. For this task, we want the JackBord to turn the user LED off when the button is released. To accomplish this, at the command line, type BTR space A1 space L1 space 0 and press enter. From now on, when you press the button, the user LED will turn on, and when you release the button, the user LED will turn off. If you find this doesn't work, remember to re-enter the BTP command from task 5 if you've turned the JackBord off since you started task 6. You now have the ability to control things with the JackBord using an external button. If you want to see a list of the buttons that are currently set, at the command line type LB. This shows a list of all the buttons that you've set so far. The LBC command will list all of the button commands as you would have to type them in the command line if you wanted to run them again. And finally, the RSTB command will reset any buttons that you have currently set. In this last task, we're going to make our own button from scratch. For this to work, you need to realize that a button, or a switch for that matter, all do exactly the same thing. That is, they bring two electrical contacts together so that the current can flow. This is exactly the same as simply taking two pieces of copper wire and touching them on each other. For this task, we need a metal paperclip. You can't use a plastic one because the outside is insulated. We need a small flathead screwdriver and your JackBord top and the JackBord. We're going to use the paperclip and the JackBord top to make a switch. But first a little bit about terminal blocks. Looking at the terminal block on the JackBord top from the left-hand side, there are three slots where you can insert a wire, or in our case, a paperclip. Looking down on the terminal block, you'll see there are three screws. There's one screw for each of the slots. The purpose of the screws is to stop the wire, or in our case our paperclip, from falling out. On the right-hand side of the terminal block, there are three pins marked 1, 2, and 3. These pins are where you connect jumper wires from the terminal block onto different parts of the JackBord or the JackBord top. Now we can start building the switch. The first thing is to take the paperclip and bend it like this so that it's in a straight line. Now use the screwdriver to loosen the screw on terminal number 3 of the terminal block. Once you've done this, insert the paperclip as shown and tighten it again by turning the screw clockwise, but don't make it too tight. Now that the paperclip is secure, we need to fold it at a 90-degree angle so that it's between the top 3-volt lines on the top and the ground on the top, as shown in the picture. Take a jumper wire and connect one end to pin 3 of the terminal block. The other end will go to port pin A1 on the JackBord. Once you've done these steps, your switch should look something like this. Take some time and double check your connections. Make sure that the paperclip is not touching the 3-volt line or the ground pins on the other side. We will use the button press or BTP command to set the switch so that when we close it, the user LED on the JackBord will be turned on. To do this, go to the command line and type BTP space A1 space L1 space 1 and press enter. This sets up pin A1 as a button input because remember, a button and a switch are basically the same thing. To press our new button, all you need to do is use your thumb or finger to push the paperclip so that it touches one of the ground pins on the right-hand side. This completes the electric circuit and is basically the same as what happens when you press a button. If all is well, the user LED on the JackBord should turn on. Now we can set what the button will do when it's released. At the command line, type BTR space A1 space L1 space 0 and press enter. Now when you press the button, or in our case close the paperclip, the laser light will turn on, and when you release it, it will turn off. This is the same behavior we observed on task 6, except this time around, instead of using the button on the JackBord top, we used your button. Congratulations, you've just made your own switch from scratch. In the next video, we'll have a look at analog inputs and measuring voltages with the JackBord. We'll also build an automatic nightlight. For more information and more videos and tutorials, visit www.jackbord.org and click on the Start Here link on the upper left-hand side of the homepage.